and see my screen?
Yeah, we can listen to you and we are seeing very well.
Great. Okay. Great. Well, thank you, Patricia. That talk really segues nicely into what I was going to talk about today. So I'm going to give a brief presentation regarding some reasonably long-term trends in parrotfish populations throughout the Caribbean. And what I'm going to do is I'm going to look at trends through time for different species, and also look at the extent to which species locally are doing the same thing, and then finally wrap up by talking about the management implications of these trends. The story behind this is kind of already been codified or laid out by Patricia, and it was really sort of set in place by this report by Jeremy Jackson and a bunch of other folks. It was really kind of the first of its time to synthesize trends in coral reefs in the Caribbean over a long window of time. And one of the key messages from this report was the story of herbivores in the Caribbean, and the fact that by the early 1980s, diadema die-off, which at the time diadema were the dominant herbivores on coral reefs and really controlled the competitive interactions between space occupiers like algae and coral. When diadema had a disease run through the population regionally, there was not a lot of parrotfish remaining to pick up the slack in terms of taking over the role of being dominant herbivores, in large part because throughout a lot of the Caribbean, parrotfishes were fairly heavily targeted. And as a result, the mediation of competitive interactions between coral and algae was reduced, and reefs started to lose coral cover. So dropping to maybe 1/6 of what once was Caribbean coral cover. And so in the report, the suggestion strongly was, let's stop fishing for parrotfish. The two sort of key recommendations was adopt some management that addresses fishing in parrotfish and restores parrotfish populations under the SPA protocol, which we've just heard quite a bit about. And I, like Patricia, and am an observer on the SPA working group for herbivorous fishes in the Caribbean. So the report suggested that under the SPA protocol, parrotfishes should be addressed in terms of conservation and recovery. And the other key recommendation was that, hey, we really need to simplify and standardize monitoring throughout the Caribbean over long windows of time to better understand what the heck's going on and how parrotfishes are responding to conservation action. Well, it turns out that there is, in fact, a reasonably long-term monitoring program in the Caribbean that's pretty simple, and that's region-wide and has very broad and deep coverage. And that's populated by citizen scientists, so divers, people that often flood the Caribbean, going on their dive vacations and jumping on boats and getting dropped off at popular dive sites. And with this program through the Reef Environmental Education Foundation, which is a citizen science marine conservation nonprofit, divers are able to take a slate down with them and a survey sheet, and over the course of their normal diving experience, when they get dropped onto that site, they can write down and record every single species of fish that they can positively identify, and they can also record the relative abundance of those fishes on a log scale. So single, few, many, and abundant. Single would be 1, few is 2 to 10 fish, many is 11 100, and abundant is more than 100. So really kind of recording objectively log scale abundance of the fishes that they've seen. And this program started in 93. Since 93, there have been over 160,000 individual surveys by divers through almost 30 years. So let's make use of these data. Let's take these reef data and see what they tell us in terms of trends in parrotfishes over time, and then look at how those trends relate to one another in terms of different species, both locally and across the Caribbean basin. And this will allow us, at least at the level of tourism diving depths, that'll allow us to say something about what parrotfish are doing through time. And as Patricia mentioned, there's not a lot of good fisheries independent data. In fact, in the Caribbean, there's not a lot of good fisheries data. So any type of long-term data like this is worthy of approach for asking questions about things like parrotfish abundance and trends through time. And because it's on the log scale, I'm just going to show a little bit of math. Because we're recording abundance on the log scale, populations in log space operate as basically a linear function. And so if we can look at the relative change in abundance categories reported through time, we expect that that approximates the change in log abundance of these parrotfishes through time. And so we do that. And we're going to take a look at these sort of medium to small bodied fishes, many of which are the characters that have already been introduced by Patricia. So we've got the queen parrotfish, red band, stoplight, princess, and striped parrotfish. I picked these both because they're fairly common throughout the Caribbean and because they're fairly conspicuous. It's easy for volunteers to be able to separate and identify these species. So I have good confidence that the data reported by reef volunteers and citizen scientists is in fact faithful to the true abundance of these fishes through time. And this is just to show you what the number of surveys through time looks like in the reef database. So you can see it started in '93 and it really ramped up quite quickly. And across the rest of the time window, we've got pretty good coverage, thousands and thousands of surveys per year throughout the Caribbean basin. So let's take a look at several different locations broadly spanning the range of the Caribbean. So here's our Pirates map of the Caribbean, and we're going to put red X's where we're going to look at trends in these parrotfishes. So we've got the Florida Keys, including Key West and Key Largo. We've got Cozumel. We've got Honduras, which includes two locations, Roatan and Utila. Then we've got the Cayman Islands to include Little Cayman and Grand Cayman. And then down in the Netherlands Antilles area, we've got Bonaire and Curacao. And then in the Virgin Islands, we've got Tortola in the British Virgin Islands, as well as St. Thomas. So these areas kind of span the Caribbean, but they also have very good coverage in the Caribbean database, reef database. So this is just a plot demonstrating the proportion of all surveys from these regions that has been conducted in each and every year through time. So what you'll notice is that the Florida Keys really and Bonaire really sort of dominate in terms of the number of surveys conducted, but there's reasonable coverage of surveys throughout almost the entire time window of the 30 years that the reef program has taken place. Okay, so let's look at first trends based on species. First, we're going to look at the princess parrotfish species. Below on the bottom, you're going to see a graph with the different trends in those species at the different species at the different locations. So here's what are parrotfish log abundances doing through time at each of Key Largo, Cozumel, Grand Cayman, Roatan, Tortola, and Bonaire. And I've split just for visualizing the data. I fit a spline to these points at the different locations, and then the matrix that you're looking at is a matrix of correlations in the time series between these different locations, where I've highlighted the cells based on yellow if they're positive, and red if they're significantly positive. And the key takeaway here is there's not a clear trend across all locations in this species through time, and that across these different locations, even close proximity locations like Grand Cayman and Little Cayman or Roatan and Utila, there aren't really significant correlations in what that species is doing. So parrotfish, like this princess parrotfish, appear to be doing reasonably different things depending on where you look in the Caribbean. They're not all following the same fate. And if we look at queen parrotfish, we see the same type of result where at different locations, the species population is doing different things in terms of trends, no strong correlations. Striped parrotfish, this is of this parrotfish we're looking at, it shows the strongest set of correlations and also the most similarity in terms of increasing trends across all locations. And this kind of dovetails with what Patricia was talking about in terms of this species being a weedy species and one that we might expect and in fact do see more of in areas that are heavily fished. So this kind of portends that across the Caribbean basin, pretty strong evidence that increasing impacts to parrotfish populations is allowing this species to expand its population generically. And then finally, maybe finally, I can't remember. Stoplight parrotfish, same thing, not a lot of clear trends. And red band parrotfish doing different things in different locations. Some positive correlations, but what's striking to me in this result is that I was expecting to see these different species to tend to do the same things in similar locations, Tortola and St. Thomas, for instance, or Bonaire and Curacao, and we really didn't see that. But let's look at what the trends based on sites is. So if we just take all of the different species that we're looking at, princess, queen, red band, stoplight, and parrot, and striped parrotfish, and then look at the trends of each of those species together in a single location, in this case, Bonaire. And again, I've plotted using both individual data points and splines, the trends in those different species in Bonaire as a whole across years. And the matrix shows you a matrix of correlations between these species. And it's all red. And the reason it's all red is because all of those correlations are very significant. In fact, some of these correlations are 90+% correlated in these species. And if I just plot without a spline, if I plot these data, then you can really see why that correlation is so tight. It's not just that the generic trends of these species through time tend to match each other, but that the year-to-year ups and downs are very tightly correlated. So species are operating as a functional group or guild and are very tightly correlated in their response to drivers, whether or not those drivers be environmental like storms or anthropogenic like increases or decreases to fishing pressure. So species act as a group, and that holds whether or not we're in Bonaire or in this case in Grand Cayman. We've seen the same results, and we see the same results in Tortola. So across the Caribbean basin, locally, parrotfish operate as a group, and they respond to things as a group. There were some locations, for instance, like Roatan and even Key Largo, where those correlations are not quite as strong. Although broadly positive in terms of correlations, individual species are tending at least a little bit to do their own thing. And I'm not sure why that would be. One might think that some of these results are due to observation, patterns of observation, just because we're dealing with divers and we don't tell them where to go. But the fact that we have the most data from Key Largo and the most data from Bonaire, and they're showing us two different things in terms of correlation among species, suggests that this isn't just an artifact of the observation process. There's something ecologically going on that's different between places like Key Largo versus Bonaire. But nonetheless, broadly across regions, when you look at a local site, those species are operating in lockstep with each other and responding to drivers the same way. And so if we take a conclusion from this, it's that parrotfish complex tends to respond to external forcing as a block. They do the same thing. If you decrease fishing pressure, they're probably all going to go up, not just one species. And if we broaden that out, there's no synchrony of common trends in a particular species, depending on where you are in the Caribbean. So stoplight parrotfish are doing something completely different in Grand Cayman than they are in Roatan or Cozumel. And so if I were to roll all of this up, I would say that there's a good news, bad news story. The bad news story is that we've got to be really responsive to what parrotfish are doing locally and within a region. And we've got to cater and customize our management to that region specifically. The good news is a rising tide floats all boat. If you can come up with management strategies to increase the number of parrotfish of one particular species, chances are really good you're also going to increase the abundance of all your other parrotfish species. And as Patricia mentioned, one of the important parts of the functional role of parrotfish as herbivores on Caribbean coral reefs is that diversity is an important component of effective control of algae and promoting the recruitment and recovery of corals. So what's good for the goose is good for the gander. If we can restore one population of parrotfish, we're probably going to do well at restoring all of them. Okay, and then quickly caveats. We talked about this is not size data, it's only abundance data. So buyer beware, we're not talking about biomass here, we're talking about numbers of individual fish. And we're also talking about where divers go. And so divers tend to visit places that fishers tend to avoid. So it may be that we're painting an overly rosy picture of the Caribbean in terms of trends in parrotfish. Nonetheless, the findings of correlation across species is a strong one in terms of how we approach management. Okay, and then quick thanks. Thanks to all of the divers that spend thousands of dollars to go diving in far-flung locations and spend all of their dive vacation poring over fish ID books and collecting data and entering them online for free, which is crazy, but it's useful for all of us because now we have a picture of what parrotfish species are doing through time. And with that, I will say thanks.